We move on to the last question of the writing part in the EoT term 3. This is on evaluating limits algebraically. Here you have a question where you need to evaluate the limit of this function as x tends to infinity. What does this mean? Now, limits is a very effective way to understand what happens to the function. Now, say, for example, you have this one. You can start putting the value of x is equal to 1 and find an answer. X is equal to 2, x is equal to 3, and you can go on till infinity, right? X is equal to infinity. So what does this tell? This tells you the end behavior. If you graph this, now imagine there's a random graph. The end behavior is something, it flattens out. That means that limit over here, as it goes to infinity, imagine this is 10, that is the limit answer. So what happens at the end? If it goes towards infinity, then the answer would be infinity. It just keeps on increasing, right? There's no limit, it's infinity. And if it goes downwards, you would get negative infinity, or say it flattens out after a certain point at -5, then that would be the limit. Now you can use your calculators to easily find this out, but since it's in the writing part, let's see how to solve it up. All you do is, see over here, there are different methods, but the easiest I personally feel is, see the degrees of x. What is the degree over here? Highest degree is x to the power 1. So divide each term by that. So we limit as x tends to or approaches, that's the same thing. Tends to means going towards, or approaches is also the same thing, to infinity. 4x plus 5 is there, right? Divide this by the highest degree over here is x, this also by x, and the denominator is the same thing, -3 divided by x divided by x. Now simplify. What is the answers? We have 4 over here because x and x cancels here also, plus 5 by x divided by, what do I have in the denominator? It's 8 and -3 by 6. Now here you must remember a rule. Limit as x tends to infinity. What is the, for 1 by x, what is the answer? It's 0. Now I'll show you how this is. Let's take our calculators. Now what is, say, a number 1 divided by 50? It is some small number, 0.02, right? But let me make this big. I'll take it like 50,000 now. It's even smaller. If I make this, say, million or billions, it's even small. It has got 11 zeros, 10 zeros, and then 2. Now if I increase this, say this to a huge number, 999 to the power 999, this is a huge number in the denominator. Okay, you got an error over here, but okay, how about this? Still an error because it's too huge. How about this? No error. Okay, how about this? So basically we are approaching 0. That's what you can see here. It's becoming smaller and smaller. The number is so tiny that it approaches 0. So this is the rule. As x tends to infinity, where x is below, down below 1 by infinity, it's 0. It's kind of like, if you remember, what is 1 divided by 0? It's undefined, right? You can't define it. But it basically is a huge number. It corresponds, okay, that's not infinity, it corresponds towards infinity. That's the thing. So 1 divided by 0 is corresponding infinity. 1 by x would be 0, but based on the limits. So here now, what we do is, we use this rule. Okay, I shouldn't have erased that. This rule. Now we can easily eliminate this and this because they are 0 and 0. So you're remaining with 4 by 8. It'll be 1 by 2. The limit is half, or 0.5. So that is how we solve it. Easy, isn't it? Now I did not write over here it's 4 plus 0 because anything divided by 0 doesn't matter the constant. It is 0, right? Because 5 times 0 is 0. So directly eliminated. So this is how we solve it up. Divide all by x's, and then over here, see, this is the actual step. What they do is, because you do directly, it's, force of habit, but technically how it is done, after this step, your limit is multiplied to each terms. Okay, the limit is multiplied. So it becomes limit x tends to infinity of 4 plus limit Over here, constants are written outside. Limit as x tends to 1 by x tends to infinity, 1 by 0, 1 by x, sorry. This is 1 by x. And everything you write. Limit of any constant is the constant itself. This limit as x tends to infinity for 4 is 4. Here this is 0, so 5 times 0 is 0. So that's what happens, you know. And the denominator also likewise. And this is what you get. Half is the answer. And you can check it with graphing as well. If you graph this up, you're going to get half. See, this is going towards infinity towards half. So y is half over there. And similarly, you can do this problem. I'll do this quickly. Why? Because over here we have different degrees. Now see what is the highest degree, and it's minus infinity, okay? So what is the highest degree here? It's power 3, right? So individually divide each term by x power 3 minus x by x power 3 divided by 3x cubed by x power 3 plus 1 by x power 3. And now we can simplify. This closes, this cancels with this, 2 is gone, you're remaining only with 1 power 2. Over here what happens is this and this goes off and you're remaining with so much. So now let's simplify them and write the limit. Don't forget the limit as x tends to minus infinity. Now 6 by x minus 1 by x squared here divided by 3 plus 1 by x cubed. Now we will apply the limit. We can apply the limit individually to each term. Now here you might think, okay, the limit is minus infinity, right? X tends to minus infinity. So will it change? Will this formula change? No, because 0 is neutral. If it's plus infinity, minus infinity, it doesn't make a difference because 0 is 0 itself. It is plus or minus, it's neutral, right? Neutral to any sign. So therefore, what we can do is we can, sort out the constants. I'll write it out over here. It'll be limit x tends to minus infinity. Since it's in writing, you have to write in detail. Otherwise, directly from calculator, you get the answers. So the constant is removed out. It's 1 by x minus over here limit as x tends to minus infinity. And over here we have 1 by x squared divided by limit as x tends to minus infinity again. Here we have 3 plus limit as x tends to minus infinity 1 by x cubed. So this is the thing. And now what you do is you substitute everything over here and you get all these zeros, right? So what happens here? It will be 6 times 0 because 1 by infinity is 0. Now even if it's 1 by infinity square, like x squared, that's also 0 only. Minus 0 divided by over here we have only 3 plus 0. So what happens is it becomes 0 minus 0 but divided by 3. The answer is 0. So this is the final answer. Don't think it's infinity because we have a number in the denominator. It's 0 divided by 3 will be 0. That's it. So that's the answer. Similarly, you can try the other problems. This is also the same thing. Divide by the highest degree. Remember, what is the highest degree here? It's power 4. So when you divide each term by power 4, you're going to... Over here, let me just show you. This is going to be 5 by 5x power 4 divided by x power 4, and over here we will have 9x cubed by x power 4 plus 2x by x power 4. And so what happens is it'll be 5 divided by 9 by x plus 2 by x cubed. So this is what happens, and then you apply the limit and you can solve it up. So over here it's just 5, and over here you have 1 by x. That 9 is out, so it's 1 by x, and 2 is out, 1 by x cubed. Yes, that's the answers. And here you get 5 by 0. Now look over here, 5 by 0. This means the answer is infinity. You will get undefined answer, right? Because the answer is approaching towards infinity. 5 by 0 is going towards infinity, right? That is the thing. The answer would be infinity here. So let us look into the EoT problems. The question number 47. It's a real world problem. A gel capsule contains a sponge animal When the capsule is submerged in water, it immediately dissolves, allowing the sponge to absorb water and quickly grows in size. Okay, the length L in millimeters of the sponge animal after being submerged in water for t seconds can be defined over here. This length is with respect to time. The length is increasing based on time. Now, this sponge can absorb a certain amount of water, and then once it's completely saturated in the sense completely filled with water, it will not increase its length. So you might have seen some sponge put drop it in the water, it might increase the length because of the water absorption, but it has a certain limit. So now that is what we need to find over here. What is the length of the capsule before it is submerged in water? So the length over here before submerging in water means what? The time is 0, right? So substitute everywhere over here time 0 and solve. You don't even need to use a calculator. Before being submerged means, see, when you start submerging, time starts from 0, 1, 2, 3, 4, 5, and so on seconds, right? But before it's submerged, t is 0. So over here, this becomes 0, 0 substrate over here. So what is the answer? This entire thing is 0 plus 25. So the length is 25 units. So the first answer must be just 25. It's given in mm, is it? I couldn't see. Yes, it's in millimeter, so it's mm. If it's not mentioned anything, then you can write in units. But since it's clearly mentioned the length in millimeters, so we write millimeters or mm. What is the limit of this function as x tends to infinity? That means over here, just now what we did, we are going to do it again. So I'll just divide only this left side. I'm going to divide by t squared. Okay, so it will be 105 divided by t squared and multiply. This will be just 105. Over here it will be 10 divided by t squared plus 1. Now when you apply the limit as x tends to positive infinity, right, and this is plus 25, both the sides you need to apply. Here this part becomes 0. Okay, you need to write limit everywhere, and this is 105, so it will be 105 plus 25, that is 130 mm. Basically you have to write the limit over here, here, this becomes 0, and then the answer is 105 plus 25, because limit of any constant is just the constant value, and the answer is 130. So 130 mm. Explain how the limit of this function relates to the length of the sponge animal. So what it is this length as time extends to infinity is the maximum capacity that the sponge can hold. The water can be held by the sponge. It cannot be more than that particular length. In its completely saturated state, that is the maximum length. Okay, I just told in detail what it is, but they have just told in simple words. The sponge animal will not grow longer than that particular length. Obviously, because that's the maximum length it can grow. Okay. Over here, another similar problem. Suppose the weight W in kilograms for a kitten D after birth can be estimated over here. What is the weight of the kitten at birth? So there's a small kitten and it's just being born. What is the weight? Weight is given with respect to the days, the time over here in terms of days is given. So at birth, how much is the days? It's 0, right? So I will just put this as 0. Okay, the limit over here, just substitute this as 0, put it in the calculator, you will get the answer. So now what happens is when you put this 0, this entire thing becomes 1, because anything raised to the power 0 is 1. So it'll be 25 divided by 2 plus 98 times 1 is 98. It'll be 25 by 100, that is 1/4. So this is in kilograms, is it? Whatever the unit is, it'll be, yeah, it's in kilograms over here that I mentioned. It's 1/4 kilogram or 0.25 kg. Now, how much will the kitten eventually weigh? That is the weight as d tends to infinity. So what happens is in cats or dogs, generally after they grow for a particular size, their weight remains constant. I mean, here and there some grams might vary, but the maximum weight of each breed of species is found out, right? So just put over here infinity. So you can just check it in the calculator. I'll just do this in the calculator now. Here, just type this question. 25 divided by 2 plus 98 times the 0.85 to the power Over here, infinity, we don't have infinity, just put a big number, okay? So the answer is how much? It is 12.5 kgs. So that's it. You can write it in detail, like just substituting, because as infinity means it'll be a big number, take the limit, this is the answer. And these are different type, okay, sequences. Now these are also pretty straightforward problems, but over here the extra part is write the first five terms of each sequence, then find the limit of the sequence if it exists. So what you need to do is first put n as 1 and solve. See, now here the limits of the terms are found out. You put a as 1 everywhere. Wherever n is, they put 1, solve it up. 2, solve it up. First 5, right? 1, 2, 3, 4, 5. What are the values? You get 0.667, 1.125. You can see it's increasing until 1.6 we got. Now they want the limit. So put infinity. Now infinity, just now we did, right? The same thing, we do it over here. Because it's in writing, you have to do it. Otherwise, I'll show in calculate how to do. The better way to do this is type this out. Don't put any number. Don't put 999 for n or anything. Just type it as a variable x. Instead of n, we put x plus 1 divided by, over here also, x plus 5. Now what we do is we calculate it. This calc symbol is there, right? Press calculate. And what value you want to calculate. So if you want to find these terms, you just put it at 1. It is 2/3 or 0.667. See? Now calculate it at 2 and you get 1. That is the term. Calculated at say 5, you should get how much? 1.6. So now I will calculate it for infinity. Infinity means a big number, some nines. How much is the value? See, it's corresponding towards 3. Now in the calculator, we won't get the exact value. You get it if you put a lot of numbers, nines. Now you got it at 3. But generally, if you get 2.999, approximate it towards 3. So this is the answer. But if you use the formula and solve it, yes, you'll directly get 3 itself. Okay, using the rule. See over here, this becomes 0, 0. So you're remaining with 3 divided by 1. So answer is 3. The sequence over here, eventually, if you keep on finding a lot of numbers, it converges towards 3. The number 3, that's where it goes. And over here, if we graph it, we can get this as well. See, it goes almost towards, it's not exactly touching 3, but it eventually will go towards 3. That's what it means. Here, another problem, same concept, okay? So over here, find few terms. Now over here, what you do, you have to divide by the highest degree. So that is, over here, before you divide, what you can do is, you can simplify how much you can. In the sense, you can use this power. What is this power rule? N plus 1 the whole square is a squared plus b squared plus 2ab, right? N squared plus 2 times n into 1 is same, plus 1. Split it out. Over here, it will be n squared times n squared plus 2n plus 1 divided by 4, and you have 5 divided by n to the power 4, right? Let's multiply this inside and this also inside over here. So 5n multiplied will be 5n to the power 4 plus 10n cubed plus 5n squared divided by 4n to the power 4. So this is the simplification we got. Now then we know what to do, which is the highest degree, power 4. Divide everything by n power 4 and then simplify and put the limits and solve it up. The answer would be 125. But if you do this directly in the calculator, you get this answer itself. That's the answers. Now the stable method cannot be done in the calculated table. If you're thinking mode 7, no, it doesn't work, because look at the jump of the values, 10, 100, 1000. That's not going to work in the calculator. If you try, it'll show you insufficient data, or you just can't get these sort of values. But there's a way easily to find it out. That would be, I'll just show you now. I've typed the given equation over here as it is, like with alpha x, okay? It's in mode 1 only, computation mode. Now calc and try different values. I'll try at 10. What's the value I'm getting? It's 1.51. Now change calc at 100. And you can see it's going 1.27. So let's change it to say 10,000 and you're getting 1.25. And you can see as I increase the values, say I'll just increase a lot, it'll be corresponding towards 1.25. Now if I increase it too much, say like a lot and lot of values. It'll be 5 by 4. Why? Because 5 by 4 is 1.25. But checking is not that needed, because if you just solve it like how we've done over here, that's more than enough. Okay, as long as you've got the correct answer. And check it using your calculator, you can easily understand whether it's correct or wrong. Now over here, it's the same thing. Please solve just like what we have done. Put A1, A2, A3, 5 values, and then use the limit. Over here, you need to divide by power 3 everywhere and solve it up. Let me do one problem here. This is only looking complicated. First, you need to find A1, that is 1 cubed minus 2 by 1 squared. Find the answer. Then A2, A3, A4, and A5. So in the exam, do substitutions for 1 or 2. This is 2 cubed minus 2 by 2 squared. And then you can rest, directly write the answers. Okay. So next thing would be limit. Limit as x tends to infinity for n cubed minus 2 divided by n squared. What would be the answer? First, you need to divide throughout by the highest degree. It will be n cubed divided by n cubed minus 2 by n cubed divided by n squared by n cubed. This is n cubed. And now what you have to do is simplify this. The limit remains as x tends to infinity. Over here also, limit as x tends to infinity remains. Solve it up. It's going to be 1 minus 2 by n cubed divided by, over here it's just 1 by n. So when the limit over here, now you need to multiply this. Exactly, I'll just show it. This one problem. So you need to write this as 1 minus 2 can be written outside. Limit 2 is a constant. Even over here 1 can be written out, or inside it's fine. But since it's only 1, we write it inside. But if there is 2x, you write x after the limit. 2 is a constant, so you take it out. So x tends to infinity. Over here you write 1 by n cubed. I'm so sorry, this is not x, it's n, okay? Why? Because the variable is n. You can change it to x, it's fine, doesn't matter. And what is divided by? Limit as x tends to infinity, it is 1 by n. Now what happens is, over here the answer is 1, here the answer is 0. It'll be 2 times 0. And now here 1 divided by 0, what is that? It's infinity, right? Because anything divided by 0 is infinity. So the answer, the final answer must be infinity over here. And these terms, how do you find out? You find out in the calculator. It'll be 1 minus 2. Let me just solve this one over here. 1 minus 2 by 1, it is negative 1. So then over here it'll be 2 cubed, that is 8 minus 2, it's 6 by 4, it's 1.5, and so on. You can find the other terms. You can just put this in the calculator directly and calculate at different values like 1, 2, 3. There's a calc option, you do it in that. And the answer over here was infinity, yes, and the other answers are over here. Please do solve all of them by yourselves. I will show you how to check the answers in calculator here. Let's do it. First, type the given equation as it is. 8n squared, that n is in terms of x over here, plus 5 variable plus 2 divided by 3 plus 2n. All right. Calculate for the first sequences, right? Calculate this at 1. And this is your first term. Calculate at 2, that's the second term, that is 6.28 and 6.29. Calculate at third, this is the answer. Same way, calculate 5 terms, because they have asked, no, they have not asked, but in the example problem they asked for 5 terms. And lastly over here. But the limit means it's going towards infinity. So calculate at 99999, a huge number, and that is the limit. Over here you can see what's happening. If you change the values of 9, it's just a huge number, right? Now it's a small number. If I increase this, it is just a huge number. So what is it? 10 to the power 14. It's billion and millions, you know. So this means it's infinity. It's going towards infinity. So the answer is over here, infinity. If it was minus over here, it will be minus infinity. So that's it. Over here, if you had solved it, you would just get 2 or 1.9999. And if you increase the number, calculate at a huge number, say a lot of 9s, you would get just 2 for this problem. You can try it. But over here, since we are getting a huge number, it's varying, it's infinity. Same way, these are the problems. Please do them all and try to at least see how it is checked by the calculator. But if you understood one problem, then it's almost the same. If you're thinking how to solve this one over here, first is simplify this, multiply them, get it sorted out, take this over here, 12 inside, and after that you'll get only one huge term like a polynomial in the numerator and in the denominator. Then see the highest degree and divide throughout by that degree and solve it out. We have a real world problem, and this is the last problem in the entire writing part. It is about population. After being ranked one of the best cities in which to live by a national publication, Northfield Heights experienced a rise in population that could be modeled by this particular equation, where P is the total rise in population in thousands and T is the number of years after 2006. So here the equation is given. You need to complete this table. The population for 2007 to 2009. So here they have clearly mentioned it's after 2006. Let's take our calculators. So here what you need to do is put this equation in. So 2007 would mean 1 because after 2006, 1 year, right? Calculate at 1. The answer is, so it's 0.397, but it's in thousands. So multiply this by 1000. It'll be 398, okay, people. And then say for year 2, calculate at 2. Here it is, there's 2430, you can say. And then lastly for the third year, oh, I just removed it. So let me just type it back again. Here we have it, and then calculate it at 3. The answer is 5000 and so on. So that is the first answer. You can see here, that's the table, 5550, because we have to multiply this by 1000, right? That would be 5550. And now what is the next one? What was the total rise by 2011? We know this is from 2006, right? 11 minus 6 is 5. So calculated at 5, the rise was 9,576, about 9,576 people. What is the limit of the population growth? Limit means take a huge number, calculate a huge number. So it's 12,000. 12 means it's in thousands. So 12,000 is the maximum population that can be accommodated in that particular city. Why? Explain why the city population growth may have a limit. Let's see, there are various reasons, right? Because a city can hold only a certain number of people. So the equation over here will generally be based on those factors. So when you find these equations, right, how generally they make it is they take a lot of factors into consideration. The environment, the growth, the economy, the school, the infrastructure, everything, and then they do these equations. So they are more practical equations. And therefore, there are lots of constraining factors which will restrict the population. And over here we have a city's border may limit the amount of possible growth and building opportunities. Yeah, this is also fine. But it's about analyzing. You can write your own answers over here when it's about explain. So write practically what you feel is the best answer. And that is the end of all the problems in the writing part. I hope you're finding my videos helpful. And I just want to first of all, thank all the students who, share my videos, who like and subscribe to my channel. It means so much to me. It is over 7,000 subscribers, and I'm really, really humbled by your support and love. Thank you very much for that. And I kindly request, if you have not yet subscribed to my channel, please do subscribe. It would mean so much to me. And do share my videos with your friends who might find them helpful. That would be a great help you can do to me. Thank you guys, and I wish you all the best. And please do stay tuned. I will try to do the part 1 as soon as possible. Bye-bye for now.